I'm going to set my start initial state at 2, 2. Then my goal is at 4, 2. What I'm going to do is BFS, but I'm not going to use the recursive one because in my thinking, in my algorithm, if I use the recursive, I'm going to find this goal so quickly. Recursive is going all the way left first, but I'm going to use the iterative way, the while loop way. That means all the way right first. So I'm going to search. When I generate child or neighbors, I'm going to go right first, then up, then down, then left. That's my rule of the searching. That means when I expand all the way left first, then down, then up, right. So I'm going to start searching it. So I need a frontier. In my frontier, I'm going to have the initial 2, 2 first. Then from the frontier, I'm going to search children action. So I'm going to do right, up, down, left. So I'm going to add right first, up, down, then left. So next round, because it is a DFS, iterative way, I'm going to pop the last one. So I start from 1, 2. Then I'm going to explore. It's not the goal, so it goes to, it generates the children, right? It's already explored, so up, so 1, 3, then down, 1, 1, then left, 0, 2. I also, whenever I generate child, I'm going to put into the explored. So I'm going to save some time to trace it. Then actually, our general algorithm was adding explored after pop it. So actually, my explored has only those 3 though. I just changed it a little bit over my algorithm. All of them are there. Then this is done. I'm gonna repop. So 0, 2. Then from here, I cannot go right, but I can go up. So 0, 3. Then I can go down. So 0, 1. Then I'm done. So it's closed. Now I'm going to pop. So 0, 1 is popped. Then search it, right? Oh, it's already there in the frontier. Down. Up is already there, so down. Up is in the explored, so down. So I'm going to add 0, 0. Then 0, 1 was closed. Now 0, 0 is popped. Then from 0, 0, I can go right. So 1, 0 is now added to the frontier. Then 0, is down because it's boundary. Then 1, 0, I restart because it's popped. Then I'm going to change the color. I can go to the right, but not up. So 2, 0 is added. Now 2, 0 is popped. Then it can go to the right. So 3, 0 is added, but cannot go up, cannot go down, cannot go left. Then now 3, 0 is popped. Then I can add 4, 0. Then I can add up. Now I can go up. So 3, 1. Then 3, 1 is popped. I can go right. So that is 4, 1. I cannot go up. I cannot go left. So 4, 1 is popped. I can go right. That is 5, 1. Then I can go up. That is 4, 2. Then I cannot go down. I Okay, now go left, so it's done. Now 4,2 is popped, then that is the goal, so done. By using the DFS iterative way, my path is this way. So long. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Length 10. But actually shortest path length is 2. So regular one, the length is 10. So what we want to do is we can do the limited search. I'm going to restart from the start. So, right, now I'm going to do DLS with limit 2. So I search right, up, down, left. Then like the regular DFS, left is popped first. Then I search up, down, left. Depends on the DFS. I pop all the way left first. But there's a problem. This is now reach the limit. It's not the goal. Meet the limit, so stop. So no more expand. That means this is done. Now I'm going to go back. The next one is actually down. So I go to the down. This is the length 2 again. Limit 2. Then it's not the goal, so stop. Next one was up. So go to the pop up. Then from here, this is also limit, so stop. 1, 2. That means all the way left branch is done. So down branch. So actually in the down branch, I can still expand right, no down, no up, and down is yes, but no left. They're explored. So now I'm going to pop. Actually, left 2 is not there, so down first. This is the limit and not the goal. Then the next one, so right is popped. Then this is the limit and not the goal, so stop. So go back to the queue. There will be maybe step. There will be the up is waiting, up branch is waiting. So you are gonna go to the up, then it's expanding to the right and up, no down, no left because they are already explored. So up, limit, so no. Then next one popped. That is also limit, so no. Now I go back to the step. There's only one left. Then we are going to start. So from here, we can go to the right only. Then next round. And here, this is the goal, so found it. So you could have found, it looks like breadth first search, but actually not breadth first search because it is, if your goal is at 0,2, you are lucky to find it quickly. So this is DLS with the limit 2. So if you are lucky, you can find it. Then iterative deepening is actually giving first depth 0, then second depth 1 only, then third time depth 2 will be searched. Then if you didn't find the goal, fourth time depth 5, depth 3, depth 4, depth 5. Bi-directional search. I'm going to have a start. Then I'm going to have the goal. Let's just say the branch factor is 3. So from the initial state, I expand 3. At the same time, we are going to do expand from the goal 2. That's a bi-directional searches. When you start from the start initial, you also start from the goal. Then next time, from the goal, I'm going to say the backward search. Then from the initial state, I can say forward. So each time we're going to do forward one level and backward one level. You can think about in one while loop, you're going to have two for loop to generate neighbors from the forward and from the backward. Now, second time from the initial frontier, I'm going to extend. After that, from the goal backward, I also will extend. The depths too are extended. Next time, I'm going to start to extend from the frontier. Let's make it mid here. Depends on how you write the code. But after I expand it from the frontier, if I have any intersection, then I can say, so intersection among frontier. So when my frontier is like here, so all the way leaf node, these are my frontier. If we meet the goal to frontier, backward frontier, if there's any extension between those two frontier, that means we found the solution. So you're gonna stop searching, expanding. Then I can say now the path is starts from the intersection point, then go to the intersection point. If I combine those two paths, that becomes real shortest path. So now it's time to analyze. I use the branch factor as 3. Then my depth was 1, 2, 3. So from the start, initial, I expand the total 3 to the third. How about from the goal? Branch factor still 3. I expand only 2. So total I expanded 27 and 9. So what is that? 36 nodes. How about if I use just the BFS? This result is by doing the BFS, bi-directional BFS. How about if I used from regular BFS? 1, 2, 3, 4, 5. Path length is 5. That means 3 to the 5th. What is 3 to the 5th? 243. Wow. 36 versus 243. How about if I was expanding 3 versus 3, then if it was depth 6, 729, then it was actually 54. Wow. How about if it was 7th power? What is 729 times 3? 2,187. How about if one of them was 3 to the 4th? What was it? Now 81 plus 27, so 108. Do you see the difference? When depth becomes deeper and deeper, 100 versus 2100. How about the depth was 10 versus 5? Ooh. How about the branch factor was 10, not 3? Bi-directional is much more efficient. So we can make the rule. A regular one was B to the this big efficiency, but bi-directional BFS is B to the half of the depth plus B to the half of the depth. What this means is actually 2 times B to the half of the depth. We do not count the scale factor. So we can say versus B to the depth over 2. Totally different. Much faster. So bi-directional is very good if you know how to find the intersecting point. This is a kind of challenge though.